Okay, so this is in class 10, question 1 continued. So we finished part A, B, and C. Let's do D now. So what is the probability that a woman has a foot length between 11.5 and 13.25 inches? So let's look at that. So we're looking at probability that the foot length is between 11.5 less than or equal to x less than or equal to 13.25. So we have to do z-scores on these to change it to a standard normal. So let's do that. So we'll do z-scores. So the first one's 11.5 minus, so the mean for women, so we're looking at the women's one. So going back up here, the mean for woman is 9.5. So minus 9.5. 9.5 over the standard deviation for women is 1.2, I believe. Just double check it. Yep, standard deviation is 1.2. That goes on the bottom here. 1.2. Okay, so then less than or equal to z, which in turn is less than or equal to z-score for 13.25. So here, so it would be 13.25 minus 9.5 over standard deviation, which is 1.2. Okay, so then this will equal, so working these out, we get then, so the guy on the left, if you work it out, it's 1.67, say rounded to 2 decimal places, 1.67 less than or equal to, z, which in turn is less than or equal to, working out the other one, is 3.125, so 3.12, let's round it to 3.13 to 2 decimal places. Okay, I claim that this will equal then, so probability z is less than or equal to 3.13 minus probability z less than or equal to the 1.67. So let me explain how I got this. Okay, so let's look at this. So down here I'm going to write probability z is between 1.67, sorry, and 3.13. So I can draw a standard normal curve here. So here it'd be 3.13 over here and say 1.67 here. So looking for this area. So I claim that can be written as, we draw another normal distribution here. So the area to the left of 3.3 so that'll be, so this would equal, and I claim probability, so z is less than or equal to 3.13, then subtract another one here. The area to the left of 1.67. So minus probability z less than or equal to 1.67. So let me explain. So let me put the 1.67 here. So now if I subtract this guy from this one, then the only thing that's surviving will be that. So this guy here. And as I'm looking for over here, you can see. Okay, so that's the reason. Let's keep going. Okay, let's keep going. So there's the picture right there. Okay, so let's keep going. So now we need to look at our z-table for 3.13. So let's go to our z-table. Looking for 3.13. There's 3.1 there. And then it's going to go 0, 1, 2. So it looks like it should be this guy here. Let's see. Actually, move this other way. Okay, so I can't see it. Let's see. Let's draw here. So 3.1, 0, 1, 2, 3. So I believe it's this one here. So let's put that guy in our Google Doc. Okay, so it was 0.9991. Okay, now next we'll find our 1.67 guy. We actually found that in part C up here already. So we can look again in the table, but we don't need to since we already found it up here. So then we'll do the subtraction. We get then 0.0466. So the probability that a woman has a foot length between 11.5 and 13.25 should be inches here. Inches is 0.0466. So it'll be basically, if you move the decimal point 2 places, or we can say or, as a decimal it'll be 4.66%. Okay, so let's go on to part E. So part E, what is the shortest foot length a woman must have in order to be in the top 10% of all women? Okay. Okay, so let X say equal shortest foot length of a woman in the top 10% of all women. Okay, so then we pretty much would have then, so note here, X, note a foot length of X would be larger than 90% of women's foot lengths. Okay, so it follows then, hence we could say the probability that X is less than or equal to small x will be less than or equal to, sorry, greater than or equal to, oh sorry, less than or equal to 0.9. No, actually it'd be better just to say equal 0.9 here. Okay. Okay, this implies, so I'll take this guy again. Well, I'll say insert here. Insert equation. So it'll be probability then that x is less than or equal to small x, doing the z on this, the z-score on this guy. So it'll be probability z then is less than or equal to, so doing our z-score, so it's going to be small x minus the mean for women. So mean for women is 9.5 and the standard deviation is 1.2, so it'll be minus 9.5 over 1.2, and this has to equal to 0.9. So looking on our z-table for 0.9 in the body of table, and then going backwards to find z. Okay, so let's go to our z table and look for 0.9 in the body of the table, so in this portion over here. Okay, so looking in the table for something as close to 0.9 as possible, you can see right here these two values are the closest to 2.9, and they correspond to, they're both on the 1.2 level here, and above one's at 0.8, one's at 0.9. Okay. Also we got z equals 1.28 or z equals 1.29. We will use a larger one. Z equals 1.29 because we want to guarantee that the small x is larger than 90%, so choosing 1.29 will guarantee this. So we're going to put a 1.29 equal to that. So let's do that down here. So that this implies then, so multiplying both sides by 1.29 we get, sorry, I meant multiplying both sides by 1.2 we get the following. And then solving for x, so we're going to add 9.5 to both sides. Doing that, we get then, so adding 9.5 to both sides, we get then x equals 1.2 times 1.29 plus 9.5. Adding these, we get 11.05, so it'll be inches. So that's our answer. So we're done. So we can say that if a woman has a foot length of 11.05 inches, they'll be in the top 10% of all women.